if we can recall the lectures what we have done as of now, especially in the sequential side. So initially we started our analysis with the flip flops, okay, which was the basic element that can store a single bit, okay, and then we come up with the registers. With the help of that flip flop, we can make the register if I have to store more number of bits, okay. The length of register that decide how many bits we can store. Suppose if I have a register having 8 bits, 8 flip flops. So what it means? It means it can save the 8-bit data, and similarly something like that. The next application of the flip flop was something like the counter that we can design, and then similarly we can also saw like the Murray and the Mealy sequence machines and the sequences, and we try to understand how it works, okay. One very important thing that is really very important, especially like suppose if I have to make a memory, if I have to store some data, so for that purpose the memory is an important parameter, okay. And we have already saw in the previous lectures like the flip-flop is a basic element that can store a single bit, okay. And if I have to store more number of bits, then I have to use the registers. So here I will be discussing like what are the different kind of memories, and then we'll come to know that what is the programmable logic memory, okay, what is the programmable logic devices and how it is different from other kind of memories, okay. So this is our objective in this particular module. So if we talk about the memory, I just told you the memory is nothing but if I have to store some data, in that case the memory is required. Basically memory is divided into the 4 categories. The first one is the registers, okay. These registers are nothing but they are inside the processors. When I will teach about the microprocessor, then I will talk about what is the importance of registers, okay. I just told you like register is nothing but they are inside the processor, and suppose if I want to execute some of the operations, and so if there are some register which are already present in the processor, so that will speed up the process. So whatever the data I am fetching from the external memory, that will first come to the register, and then processor will execute all the operations with the help of registers only, so that the speed can be enhanced, okay. So but yes, the important thing is we cannot have the register with high capacity, okay. The capacity is limited in the processor. The capacity of these registers are very limited. We can store very limited number of data, okay. So this is what the registers are. Cache memories are like there are some memory in between the primary and the processor that can again that is utilized to enhance the process, like to speed up the process. The cache memory is required. The primary memory is like the memory which are required for the processing, yeah. So these all are the memory. Secondary is like if I have to use some data to store some data in bulk, then secondary memory is important, okay. The main focus of this lecture is like the programmable logic devices. If I have to make the primary memory or the main memory for any of the system, any of the computer system, in that case the programmable logic circuits are very important, okay. And that we have to understand how the programmable, how we can program any of the logic to store a particular logic, okay. So suppose I have some logics and I want to store something, I want to execute some of the operations. Suppose I have a programmable logic and I want to operate some of the addition of 2 bits. So with the help of this programmable logic, I can design this logic in a such a way that can perform as a adder circuit. So the programmable logic is nothing but they are some raw logics, and based on our requirement, we can design those raw logics for a particular operation. Let me repeat it again what I'm saying. The programmable logics are those logic devices are those structures at which they are the raw data, like, and based on our requirement we can program them, Okay, I will tell you in more detail later on so that you will be able to understand. So in this particular lecture, we are going to focus on the programmable logic only. Okay, so this is important thing. But before we start explaining the programmable logic devices, we should know what is the memory hierarchy in the computing system that we should understand. Okay, what are the different hierarchy that we have to see? So if I'm talking about the central processing unit on the CPU, we have the arithmetical and logical unit that can perform the arithmetical and logical operations. Okay, but I just told you for these arithmetical and logical operations, there are some memory that are present in the CPU, and we can call those memories are the internal registers. And these internal registers are basically to speed up the process, like they fetch the data from the external memory, and then they execute it, and then they used to give the output. Okay, so these internal registers are basically utilized to perform arithmetical and logical operation in the memory. How it perform arithmetical and logical operation, we'll see when I will talk about the microprocessor. Okay, the next one is like the primary memory, basically where we are storing the primary data. Okay, so these are the primary memory, and the cache memory is basically a memory in between the primary memory and the CPU that is utilized to speed up the process. Okay, so in between it is processing, the primary memory send the data to the cache memory, and then this cache memory can directly connect with the CPU to operate to get the data, to fetch the data. Okay, and then we have the input output processor, and in between input output processor we have some external memory or the secondary memory to store the bulk data. So this is how the different hierarchy I have to follow if I am making a computing system or computer systems. Okay, so these are some important thing that is important. So the key point to understand from this particular slide is like the internal registers are placed inside the CPU. Okay, primary memory is basically to execute some of the operation. Cache memory is used to speed up the process, like whatever the data I have in the primary memory, the cache memory used to get it, and then when needed by the CPU, immediately it used to provide it. Okay, this is the cache memory, and if I have to store some bulk data, then I need some secondary memory. So this kind of memory I can use. Okay, so this is the important thing that we have to understand. Next and very important thing is, like, suppose I just told you, like, suppose I have to make the memory. So suppose I have a single block like a flip-flop. Okay, suppose I have a flip-flop. Okay, so in this flip-flop, I have some input, I have some output, and based on this input and output combination, I can decide whether I have to store some data on it or not. And what data I have to store, like either I have to store 0 or I have to store logic 1. So this is what the single bit memory can be, single bit flip-flop or single flip-flop can be used. Similarly, if I have made a 4-bit register. Okay, so 4-bit register means what? This 4-bit register can store the memory, like 4-bit data can be stored. Okay, and based on the input output combination, at which of the memory I have to store, like suppose there is a control signal, read write control signal. Okay, so if 0 0 is there, then the data will be written over here. Okay, if the control signal like is 0 0, this control signal is 0 0, so the data will be manipulated at this position. If it is 0 1, then data will be manipulated at this one. If 1 0, then it will be manipulated by this one, and 1 1 that indicates this one. So based on this read write control select lines, read write lines and the select line, based on the status of all these things, I can decide at which of the location I have to manipulate the data, and then I can take the data output from all the bits. Okay, so this is the important parameter that I have to understand. But what happens? Okay, let me repeat it again what I just said. Suppose I have a 4-bit register. Okay, so on this 4-bit register, I can have two kind of control signal. One control signal will be the read write, that can decide whether I have to read the data on this register, or I have to write the data. Okay, suppose I have decided to write the data. Okay, then how to decide the read and write, I will tell you later on when I will talk about the microprocessor. Okay, how to decide whether I have to read the data or I have to write the data. This is a very simple logic, and I will tell you later on. Okay, so initially I am considering I want to write the data. Okay, but what data I have to write, that is decided by the select line. Okay, select line decides the data where I have to write the data. Okay, so if the select line combination is like, if I have 4 bits, so this select line bit will be of 2 bits. Okay, this select line will be of 2 bit. Okay, so if the select is 0 0, then the data written will be here. If 0 1, then here, 1 0, then here, and 1 1, then here. So this is how it can perform. But what happens if the size of memory is keep on increasing? Okay, then how we decide where I have to read the data and where I have to write the data? So let us try to increase the memory, and we can see here. Okay, if we try to see here, I have just made here 4 cross 4 array. What it means, it can store up to the 16-bit data. Okay, it can store up to the 16-bit data. Now, someone may ask why we are using this row as well as column kind of structure if I have to use 16-bit. Why I'm not using like this kind of structure where I'm just making a 16-bit register, okay, where I can have this one. So the important thing is, like, if I'm using this one, so in that case, the total number of bits, like select line requirement will be the 4, because 16-bit is in this one. So total number of bit, like the select line requirement will be 4, and accordingly we need to use a decoder. But if I'm using this kind of arrangement, like 4 cross 4 kind of arrangement, in this one, the control signal on the row side, that will be, there are 4 possibilities. So 2 control signals required here, and 2 control signal requirement will be here. So based on that, I can decide like where I have to write the data or read the data. Suppose if I have selected 0 0 here and 0 0 here, what it means? It means that the first row will be selected and the first column will be selected. First row, first column, what it means, I have to do some modification at this node. At this flip-flop, I have to read or write the data. Similarly, if I have selected 0 1 and 0 0, what it means? 0 0 means this one and 0 1 means this one. So here I have to write data over here. Okay, but if I'm not selecting this column one, okay, if I'm not selecting this one, and if I have decided like 0 1 or 1 0, let us assume I have decided 1 0 on the row side. So what it means, it will activate all the flip-flop, but at which flip-flop I have to operate the operation, that will be decided by this one. Okay, so unless I will not give some of the control, some of the sequence from this column side, it will not decide which of the flip-flop I have to perform the operation. Okay, so if I have given 0 0, so it will perform with this one. 0 1, it will perform with this one. 1 0 means this one, and 1 1 means this one. So based on all these combinations, we can decide at which flip-flop I have to change the data or manipulate the data. So this is how we can decide 4 cross 4 array of bits. Similarly, if I can make 8 cross 8, 8 cross 8 is also possible. So in that case, I can decide something like this. Okay, so if like in this case, 0 0 0 is required, and like 0 0 0 2 1 1 1 will be here, and here 0 0 0 2 1 1 1 will be here. Okay, So row and column I can decide based on this, and I have where I have to store it. Suppose I want to store some data at cell number 37. So I have to select this row 4 and I have to select this column 5. Okay, so to select this column 5, I have to give the address, column address, that will be 101, and to select this row 4, I have to give the address like 100. So if the row address is 100 and the column address is 101, what it means, 37th number of cell will be selected, and I can perform the read or write operation at this cell. Okay, so this is how it can be performed. Okay, so this is all about the memory basics and its fundamental. Okay, and address, how we decide the address, this has been given by this one. Next and very important thing, like how we organize the memory. Like memory organization is really very important. Now like if you see here, I'm talking about the row address, column address, but how this row address and the column address is given. Okay, how these are decided. Okay, so if we try to see the detail of this memory organization, so let us try to talk about the memory organization, how the memory organization look like. Okay, so see here, this is the complete structure of memory. Okay, and how the memory is decided, let me tell you. The size of memory is 2 to the power n cross m bit. Okay, 2 to the power n cross m bit. For that purpose, because I need some row address and some column address. Okay, so but let us assume I have a 2 to the power 16 cross m. What does it mean? It means that 16 cross 2 to the power 16 cross 8. 8 indicates that here, if you see here, the whatever the n is given here, this n is nothing but the number of lines that will be in the row side. Okay, so the total number of lines or the decoder lines will be from 0 to 2 to the power n minus 1, so that you can get to 2 to the power n. Okay, so 2 to the power n, that decides like how many decoders lines will be there. Okay, now suppose I have a 2 to the power n line in the row side, and m indicates the address one here in the input output buffer, whatever data lines we have given over here. Okay, if m is equal to, let us assume it is 8. So what it means? It means that 8 number of pins will be here that can decide the address. Okay, now the important thing is of understanding here is, let us assume the size of memory is 2 to the power 16, and let us leave this part. What it means, the total number of possibilities will be 2 to the power 16, and 2 to the power 16 will be huge number. Okay, 2 to the power 10 is 1024, and then you can calculate it, what is the 2 to the power 16. Okay, so 2 to the power 16 will be something like 6061, something like that. Okay, more than 6,000 line will be required. But the important thing is, if more than 6,000 lines are required, so the bit pattern will be like 000000016 to 111111. So this much of address is required and on the decoder side, and this is really very tricky. This is very difficult. Okay, so the considering this 6,000, more than 6,000 line, the decoder line. Yeah, let me go back to the previous slide. In the previous slide, what we saw, if I have a 0 to 7 here, so I need 3 bit 000 to 111. So 3 bit is easily doable. This is possible. Like I can make the these things. But if I have more than this, like 16 bit, 16 0 to 16 1, so this will be very difficult to manage. Okay, so to manage this one, what I can do, to manage these all things, I can use some decoder circuit. Okay, decoder circuit, what decoder circuit says? Decoder circuit says that if I have m number of inputs, then I can get n number of outputs. Okay, so let us assume if m is equal to 3, so the n will be 16 in this case. Sorry, n will be 8. Okay, so you can calculate like what decoder you need here, because you need total 2 to the power 16. Okay, so what you need a decoder having 16 input and 2 to the power 16 output. Now this is how you can manage with the help of 16. Then again with this 16 you can make one more decoder which can give you the four inputs, and based on that one. So the minimum number of control signal or minimum number of input can decide the maximum number of the row values or the decoder lines. So we need some memory address registers, and based on that we can generate the 2 to the power n minus 2 to the power n number of decoder lines. So these are some of the important things that how the memory looks like. Okay, so the address line will be given, and then decoder will decode it, and that will generate a different set of outputs. Okay, so if it is n, the output will be the 2 to the power n number of output it can give. Okay, so the total number of output will be the 2 to the power n. So we don't need 2 to the power n number of combination, we need only one address, n address lines. Okay, and similarly m indicates like how many data bits and data lines are there. So this is how the memory looks like actually. Okay, so this is the simple structure of memory. If you have any doubt at this point, you can ask the questions, because this is something that you have to understand in detail. When I will talk about the microprocessor, we'll try to check it out how the memory mapping is possible, how we can map those things. Okay, so this is the memory organization. Yeah, one more important thing is like if I have to read the data or write the data, memory buffer register that decides like I have to read or write data. Let us try to see here. R/W bar is given. If this signal is 1, what it means? Read operation will be performed. And if this signal is 0, then write operation will perform, because 0 and if this signal is 0, what it means? The write bar will become, and write bar means write will become 1. Okay, so based on 0 and 1, the read and write is possible, because we are reading the data. So we are reading the data and we are writing the data, so we can make it like it is the bidirectional one. Okay, so both kind of operations are possible here. Okay, so this is how the memory organization will look like. Now one more important thing is how we decide the processor size. Suppose someone may say like 32-bit processor. What does it mean? It means that what is this M? Okay, so that there will be 32 lines over here, and based on that there will be a 2 to the power n number of rows here. Suppose I am talking about 8-bit processor. So in 8-bit processor, the order will be something like this. There will be 8 data lines. So the data lines will be 8, and based on that you can decide the decoders. If I have a 4-bit processor, so the data lines will be 4, and accordingly you can decide the things. So the number of bit in the processor that decides like how many what is the order of this one. Okay, what is the value of this M, and this is what it decides the processor size. Okay, and accordingly it can operate the memory as well. Okay. So let us take some examples so that will help you to understand the size of the memory. Okay, we know that 8-bit is nothing but this is the 1 byte. Okay, 8-bit is nothing but this is the 1 byte. Okay, so let us try to considering all these things. Let us take some example. The first example is, what is the capacity of memory having 32 address line and 8 data lines? 32 address lines means what? If we can go back to the previous slide, here in the previous slide we had 2 to the power n into m, where this m indicates the data lines and n indicates the address lines. Okay, So we have to use this formula, 2 to the power n cross m bit. Okay, so 2 to the power n cross m bit means what? Here I have to use 2 to the power n cross m, and here n is equal to 32 and m is equal to 8. So if I try to solve it, how it will look like? The capacity of memory, okay, memory will be 2 to the power 32 into 8 bits. Okay, and then what we can write, if we try to simplify it, it will be like okay, 2 to the power 3 into the power 36, like, yeah, this will be like, if you try to solve 2 to the power 32 into 2 to the power 3 bits. Okay. So if you solve it, 2 to the power 35 bits. Okay. If we try to solve it, 2 to the power 30 is the giga. Okay, 2 to the power 30 is the giga. So what it means, we can write here, if we try to simplify it, or simply here only, let me write it properly. This value can be written as 2 to the power 30 into 2 to the power 2 into 2 to the power 3 bits. Okay, 2 to the power 30 is like 1 giga. 1 giga. 2 to the power 2 means that will become 4, and 2 to the power 3 means this is 8 bit, and 8 bit means the 1 byte. So 4G gigabyte, you can write the byte over here. So this indicates 4GB, capital B. Okay, this is equal to the 4 gigabyte. Okay, 2 to the power 3 is nothing but this is equal to byte. Okay, 2 to the power 2 is 4, and 2 to the power 30 is the giga. So that will become the 4 gigabyte. If I want to write in terms of gigabit, then we can also say it like 2 to the power 3 is like 8. Then 8 into 4, that is 32 gigabit. Okay, so small b is the bit and capital B is the byte. Okay, so either we can call it 4 gigabyte or 32 gigabit. Okay, so this is the important thing. Okay, so one more question let us try to take, and then we'll solve it. Okay, what is the capacity of memory having 16 address lines of row decoder, 8 address lines for column decoder, and 8 data lines? Okay, so the column and 16, so total memory, like the row decoder and the column decoder has 16 and 8, and then 8 data lines. So the total capacity will be 2 to the power 16 into 2 to the power 8. This is the capacity of memory, and then I will talk about the 8 lines, 8 bits. Okay, so if I try to simplify it, you can calculate it, what is the value, something like this. Okay, so just simplify it, 2 to the power 16 into 2 to the power 8 into 8b. So this will come around 2 to the power 24 into 8 bits. Okay, and 2 to the power 20 is nothing but this is equal to the mega. Okay, this is nothing but this is the mega. So you can write like 2 to the power 4, that will come to the 16 megabyte. So this will be the memory size. So these are some of the questions that you can solve based on these values, and these are something easily doable. Okay, so based on that, let me give you some questions. Like here are some tutorial questions. that you have to solve. How many byte can be stored in 16 TB? Small b is given. So remember, this is the bit. Okay. How many address lines and the data lines are required? Okay. The memory has a 48 TB here. Capital B is given, so it is byte. You can solve it. The memory has a storage of 32 gigabyte, and you can solve it like this one. So there are some questions that you have to solve.